Okay, so the exponential function e to the x is in behavior exactly the same as a 2 to the x or a 3 to the x or 10 to the x for that matter. The number e is approximately 2.71. So it's a bit like pi, okay? So in actual fact, when we talk about e to the x graph, we're talking about a graph that behaves a little bit in between 2 to the x and 3 to the x. And you can sort of see that down here. There's my 2 to the x graph. Here's 10 to the x. Well, e to the x is in between. That's the same as saying 2.7 to the x in reality, okay? So it's got all the same common features as you would expect um, for any exponential graph. So let's have a bit of a look here at just some of these transformations that take place. I might just split this up. So we've got 4 sections. So what have we got? We've got 3e to the 2x. So if you like, remembering that f of x is equal to e to the x, because they're not too involved with doing we could do the x dash y dash approach, but I'm just going to rewrite this as instead the 3 times f of 2x, isn't it? Okay, if f of x is e to the x. So the 3 out the front, that's from the x-axis, and that 2 there, that's the same as, remember, of having f of x on a half. And that makes it a dilation by a half from the y-axis. Okay, so you just got to remember that that's that 2x in the 2x that we substitute into the function is not a dilation by 2, it's a dilation by 1 on 2. All right, so what about b? What would b become? B would become negative f of 2x minus 2. So we've got a reflection, okay, about the x-axis because it flips upside down. Again, the 2 inside is dilate by a half from the y-axis, and the negative 2 moves it all down. So we're going to translate 2 units negative y direction. Okay, a little bit tight to write. So what about the next one? We've got the function f of x will be equal to negative f of a half x plus 2. Yeah. So hopefully that makes sense, because once you've got it into this form here, so it's reflect about x axis. Now this time it's the same as saying x on 2, so it is dilate by a factor of 2 from the y-axis. That's close. And 2 units up, translate 2 units positive y direction. Finally, the last one we've got, f of x equals, now remember I always talk about how, let's write it as e to the minus x minus 1. Always write it as the coefficient of x is positive. Yeah, so that's the same as f of negative x minus 1 minus 1. So the negative inside is going to reflect, but it's going to be about the y-axis. And in actual fact, we have 1 unit in the positive x direction. Translate 1 unit positive X direction and translate 1 unit negative Y direction. Sorry about the writing, it's pretty hard to read, isn't it? So it's moving down, it's moving right, and it's reflecting about the Y-axis. Righto. What else we got? State the transformation required from the graph of. Okay, so we're moving from, I guess, if you like, this transformed graph back to the f of x graph. So we might even approach this one, the old x dash y dash. Okay, so if I've got y equal to, let's give that a go, 2e to the x minus 1 minus 3, that means y plus 3 over 2 equals e to the x minus 1, and I want that to become y dash equal to e to the x dash. So don't forget, normally we start with y equals e to the x, and we translate it into y dash. That becomes the new graph. Now we have our y dash plus 3 over 2 equals, etc. But this time it's a little bit different. Okay, we're starting with a transform graph, and we're moving it into y dash x dash. So what does that mean? That implies then that y plus 3 over 2 is equal to y dashed. X minus 1 is equal to x dashed if you just equate the x coefficients and the corresponding y value. So what we're saying is x dash is equal to x minus 1, y dashed is equal to y plus 3 on 2. So we could write it as y on 2 plus 3 on 2, couldn't we? So that means my new x and my new y is equal to x minus 1, and we'll write it as y on 2 plus 3 on 2. So notice we didn't have to rearrange this time to get x dashed is equal to y dashed is equal to. Okay, just because the transformations, if you like, were taking us back to the original graph. So what transformations did we have to apply? Okay, so if we look in here, we take 1 off the x value. So it's translate 1 unit to the left. Okay. And then what have we got in here? So it's y divided by 2. So we're dilating the y value by a factor of 1/2. So if the y value dilate by a factor of 1/2 from x axis, and if we're going to do that, then we translate, we add 3 on 2 to the y value, so it means we're moving up, don't we? 3 on 2 units in the positive y direction. Okay, now just if we have a look at it, if we'd have written it this way here, over here where we've got the y plus 3 on 2, we could have actually said add 3 to the y value and then dilate by 1/2. Yeah, so we could have done the translation and then dilated the translation, which would have changed it to a 3 on 2 movement. All right, but typically we have our dilation separate to our translation. So we normally do our dilations and reflections first. So does that kind of make sense? Well, I guess the key one is the graph was -3 units below the axis. And here I'm saying I've got to move it 3 on 2 units in the positive y direction. So that's promising, isn't it? We're sort of moving it in the right direction at least. The fact that it's not a 3 is because it's the dilation factor in there. Okay, we know the x minus 1 moves the whole graph to the right 1 unit. So over in here, we spoke about how we had to move the whole graph to the left 1 unit. So again, I'm confident that we've got it right. Example 8, sketch each of the following over the implied domain and state the range. So it's going to move down 2 units. So I might just move that up here. So x-axis, y-axis. Normally our graph goes through there, but our horizontal asymptote's been moved down 2 units. So it goes from 0 to there, so y equals -2. Now we know the whole point comes down 2 units and 1 unit to the right. So I reckon our graph looks like that. Each of the following, it doesn't say to find intercepts, so I put it right through the 2. So let's just check to find a y-intercept and an x-intercept. Y-intercept, let's put x equal to 0, and if x is equal to 0, y is equal to e to the -1 minus 2. And e to the -1, remember, is 1 on e minus 2. Now 1 on e is about 1 on 2.7 minus 2, so it's a little bit above -2. So that kind of fits. Let's come over here. X-intercept, I put y equal to 0. So I get 0 is equal to e to the x minus 1 minus 2. Take the 2 across. Now again, we haven't quite got to, we'll do this in the next exercise, but there's my base value. So log base e of 2 is equal to x minus 1. So x is equal to 1 plus log base e of 2. Now that may not make a lot of sense just yet, depending on how much you remember from year 11, but that's the exact value of it. What we do need to do though is state a domain and range. So again, the domain is clearly R, and the range is from what? -2 to positive infinity. Okay, righto, let's have a look at B. Let's just move it up a bit. So, well, there's a little bit in this one, isn't there? So I'm going to expand that bracket through. Y is equal to a half E. I'm going to take that negative sign out the front and make that a positive x minus 3, I think. No, plus 3 plus 5 on 2. Let's just check to make sure we've got that right. If I multiply the negative sign in, I get negative x minus 3, which isn't right, is it? So let's check that. Negative x times a positive, negative is positive. So that becomes 3 minus x, which is that. That's good. 5 on 2 is right, so that looks better. So what am I going to end up doing? I'm going to dilate. Okay, so it's a half. So it's going to be a half from the x-axis. I'm going to shift the whole graph up 5 on 2, and I'm going to move the whole graph, I'm going to reflect it, and also translate it to the right. So I'm going to start with my axis here. Okay, and just keeping in mind, the graph typically starts off with that. Negative sign inside takes it that way. Okay, now I'm going to start doing a few things. Let's move my asymptote. So I might even just, can I just erase those? Now that we've got the basic shape, I'm going to move my asymptote up 5 on 2, which is 2.5. So what if we just move the asymptote to there? So y equals 5 on 2. So it's reflecting about the axis and moving 3. So it would normally It's going to go through there. I probably moved it a bit high, doesn't matter. So that's where it goes, and it's going to go 3 units to the right. I might have to start it. Let's start it again. Only because I want to move that horizontal asymptote down lower. Let's start somewhere like this. So now, there's my horizontal asymptote. Y equals negative, positive, 5 on 2. So that's where it would normally be. And we've got that shape from what our discussions were earlier. And it's going to go 3 units to the right. So it's going to go about there. So I'm thinking our graph will go somewhere up like this. Okay, so let's just check some, well, we've got Y-intercept. So the Y-intercept, let's put X equal to 0. I get Y is equal to a half e to the negative, negative 3 plus 5 on 2, which is a half e to the 3 plus 5 on 2. So e to the 3 is about 2.7 cubed. So 3 cubed is 27, 2 cubed is 8, somewhere in between, call it about 20. Half of 20 is 10, so about 12. So it's quite a high value, isn't it, that intercept? I guess we could show that if we try to find an X-intercept, I'll put Y equal to 0, so I get negative 5 on 2 is equal to a half e to the negative x minus 3. Divide both sides by a half, or times by 2, we get negative 5 is equal to e to the negative x minus 3. And for that, there's no solution. E, remember, it's like having 2 to the negative x has to equal negative 5. And there's no number that you can raise 2 to, no power, where you get 2 to the power of something will give you a negative value. Okay, so I'm pretty comfortable again with that, domain and range. Domain for my exponential graph is R, and the range in this case is from, well, we've got 5 on 2 up to positive infinity. Alrighty.